Good morning, happy Monday morning. I got a day off, so kind of happy about that. Yeah, today is Columbus Day, so it's a kind of holiday. So yeah, good to have day off, right? Every once in a while. Yeah. So yeah, let me get some water and so let's talk about chapter 5 of this general relativity disproof paper. Uh, It'll be just some accounts of special relativity disproof that I forgot to put in the first paper. So yesterday we got a lot of whiteboarding. Um, so, but I think it behooves us add one more, and this one will be about general relativity disproof, um, which uh, is two-dimensional trajectory of photon. Okay, so um, photon does not bend in gravitation. Why? It has no mass. Period. Okay, so Mr. Einstein was very wrong about that, and we expressed that view in the paper, and that's good. That part is done. Uh, but when it comes to accelerative force, the that we call ethereal wind force, yeah, light does bend because light occupies finite space. It has this physical existence. It just does not have any mass or electromagnetism. It's neutral on that. So, okay. How about resistance force? Like frictional force. Does it affect light? I give you a minute, okay? Frictional force. Does it have any force over light? I give you a minute, okay? Hint: I may have to modify what I've wrote so far, okay? Because the answer is yes. Okay, so friction force, it does have force over light. Okay, so light is subject to uh, frictional force because light does slow down in water and also in glass. Okay, yeah, so modification, it is slight modification. Yeah, light is not exclusive citizen of the uh, third kingdom. Okay, because light is also subject to friction force, but it's not subject to electromagnetism or gravitation because light has no mass, it has no electricity or magnetism. No. But light is subject to friction force because when you go through glass or water or in the air, it does slow down. Okay, depending on the density, right? Yeah, yeah. Okay, no problem. It's a minor modification. It's not too big of a deal, actually. Okay, so light is subject to. Let's do some sort of experiment, okay? So, in the accelerative force, if rocket is going that way and light is going this way, then uh, it's kind of look like the gravitation. Like you toss a ball and it makes this parabolic trajectory, correct? Yeah, it's like that. Okay, so if the rocket is going that way, upward, out in the space, and constant velocity, yeah, then the inertial, not inertial, but well, if rocket is going that way and the rest of the world is going downward, right? So the vector summation of two force, two velocity, light going that way, and the rest of the going well going this way. So light will look like going diagonally, straight line. Okay, but if this rocket is accelerating, then yeah, it will look just like gravitation, right? Yeah, light trajectory. That's because light is subject to uh, ethereal wind, accelerative force, right? Yeah. Hmm. And but yeah, we can write that. So how about this friction force? Let's think about a scenario where, due to frictional force, light makes this kind of parabolic trajectory. Can we think of something like that? What if you have some medium, transparent medium, right? But the density kind of decreases, increases. You have this kind of three-dimensional cube or prism, okay? But we variate the density of that medium, glass or whatever, maybe some liquid, right? But like a gradual change in density of this transparent medium, okay? To make light light trajectory kind of curve, or parabolic kind of curve, not straight line. Let's see how we can do that. Well, you have water, light goes this way and then light bends, right? But it's the straight line, right? But if the density gets of this water, let's say we put some salt in it, right? Or glass, right? Tinted glass, yeah, we can variate the density of this medium, right? So that light actually goes this way and then it goes that way. Okay, yeah. That can be done. Yeah. Mm-hmm. Yeah. I was thinking about moving this glass like upward, but it's that's not even necessary. Okay, as long as this glass, this medium, have some varying density, yeah, then light will make a curve. Yeah, just like parabolic kind of. right? Depending on the density change, the change of density, the gradient, all right? Yeah. All right, we'll take 5 minutes break. Okay, so. All right. Okay, so we redefined what ether wind is, right? Because if, like Michelson-Morley experiment, if the Earth is moving constant velocity around the sun, so there will be ether wind. That's wrong notion. Why? Because an object moving in constant velocity, uh, in space, when there's no air, then there's no wind force. Why? Because if there is force, that means this object is accelerating. Okay, so we are correcting the definition of what ether wind is. Ether wind happens only when acceleration is, and only when there's some kind of force. Okay, all right. I mean, in the air, on planet Earth, if we drive a car with open top convertible sports car, right? Or you also open the window, or maybe you're just running the same speed, and then there's wind, that's air wind, and it does have some force, right? That's resistance force, and because air, they want to stand still, and you are moving constant velocity, it's as if wind is blowing constant velocity towards you when you are standing still. Okay, yeah, okay, very good. A lot to write about. Another thing, Mr. Einstein, at the beginning of his general relativity, his another error was this. Okay, he said a rocket accelerating is equivalent to a man just standing still on Earth, feeling the gravitation. It's not. They're not equivalent at all. Why? Because let's say this rocket man, is accelerating, right? So he will feel this accelerative ethereal wind force, right? Yeah, his body will be pushed down. But let's say this astronaut also has accelerometer that measures acceleration. You will read, yeah, 9.8 meter per second squared, or whatever acceleration it has, the rocket has, right? But when this Rocket Man is standing still on the surface of the Earth, and he reads the accelerometer. Will it read anything? No, it won't. Why? Because this planet Earth is not accelerating. That's big difference. Mr. Einstein, he missed it, and so did all the physicists. Okay, who believe in his theory, they all missed it, big time. And our body is, it can sense acceleration too, because we have mass. Accelerometer is nothing but some kind of some sophisticated equipment, but in principle, it is nothing but a pendulum. Okay, you have a car, you have a pendulum, some string, and some weight, right? But if your car is moving in constant velocity, it will be upright, perpendicular, 90-degree angle. Okay, the pendulum, right? But if your car start accelerating by your engine force of the car, then this pendulum will make some angle theta and lean backward. Okay, so that's how accelerometer works in principle. Okay. Yeah. So an accelerating rocket, yeah, there will be non-zero accelerometer reading. But on surface of the Earth, gravitation, there will be zero reading in the accelerometer because the Earth is not accelerating. Big difference, okay. Mr. Einstein missed that. They are not equivalent forces. The inertial, I mean, yeah, inertial force, accelerative force, right, and the gravitational force, they are not equivalent as whatsoever. Okay, so big mistake. Okay, yeah, it's hard to believe. Thousands, if not millions, of physicists missed this one simple fact for 100 years. Isn't that surprising? I find it very surprising. They're professional physicists. I mean, mistakes, it can be made. We're human beings. But for 100 years, it's as if all these people, thousands and hundreds of thousands of physicists, have been blindfolded. Why? Part of that is political. Yeah, hyper pro-Semitism. Okay, during the Holocaust, World War II, yeah, European Jews were persecuted, anti-Semitism, and Nazi Germany. So people feel sympathy about Mr. Einstein's cause, Zionism, and yeah, I think I like Zionism. Okay, yeah, the establishment of state of Israel, I think it's a good thing. Yeah, they have a country now, right? I think it's great. Okay, I'm not anti-Semitic, but I'm just trying to understand why this Einsteinian error has not been corrected for 100 years all around the world. Tens of thousands of professional physicists, PhDs. We're talking about Sorbonne University or École Polytechnique, École Normale in France. Germany, you have Göttingen University, you have what are some big universities in Germany? Heidelberg University, right? And yeah, in Swiss Zurich, Swiss, the engineering big school, what, ETH or something, Mr. Einstein got his PhD from. Yeah, big engineering school. In England, you have Oxford, Cambridge. In America, you have Stanford, Berkeley. You have University of Chicago. You have Harvard, Yale, MIT. You have Duke University. Okay. In Japan, you have Tokyo University and Kyoto University. In China, you have Beijing University. In Israel, you have Hebrew University, and also there's another one big university in Israel. I forgot the name. They all missed it 400 years. That's very hard to understand, but we kind of know why. Yeah, this hyper pro Semitism, the sympathy toward the European Jews, which is very understandable. Yeah, human compassion is a virtue. There's nothing wrong with human compassion. But when we deal with science, we don't want emotion, human emotion, to intermeddle, okay? Because that's not science. That's emotion. Okay? But we understand as humanologists. Interesting. Yeah. We'll take 5 minutes break, okay? I'm gonna jot down this note in my cell phone, okay? So, very good, very good. Yeah. Yeah, good discovery right here. So, very good. All right. Okay, so we are on the ball. Let me turn on the heater. Getting chilly. So, uh, another error Mr. Einstein made is this. Okay, it's something very basic, elementary physics, and also very fundamental one. Okay, and he missed it. Okay, he was not a very good student. Okay, he failed college exam once, so he studied for another year and he got in. Okay, he managed to get his PhD, but his GPA was not that good. Okay, it's this. In Newtonian physics, okay, there's this concept in physics textbook, like very elementary, maybe college physics or high school physics, okay. Uh, it's vector summation of forces, okay. So the net sigma total force, if you have a lot of arrows, vector force notation, okay. If net force is not zero, only then acceleration happens. Okay? Now, I'm sitting and then there's gravitational force, but I'm not moving, I'm not accelerating. Okay? Why? Because this is kind of like friction force. Okay? I forgot how they call it. My chair and the floor is lifting me up so that I don't fall toward the center of Earth, planet Earth. Okay? But if there's an earthquake and the planet Earth opens up its mouth, then it will devour me. I will fall into this deep hole during the earthquake. And in Alaska, we do have earthquakes every now and then. Okay, big one every 50 years, more or less. Every 5 decades, we have big earthquake in Alaska. Okay, because it's periodical. Okay, so earthquake, yeah, it's not. You can exactly tell the time and when it's gonna happen, but roughly about 58 years. Okay, it has to do with this tectonic movement. It's like a spring accumulation of this potential force, right? Potential energy, like a spring. Okay, yeah, plate tectonics. It's just like spring. Okay, so uh, unless I have earthquake and this house floor, this house split in half, and earth open up its mouth and swallow me up toward the center of the earth, then I will go to hell, right? Yeah, center of the earth, like magma, okay, molten, this mantle, whatever. Earth core. Unless that happens, okay, the gravitational force that pushing me downward and this resistant force of the floor lifting me up is in harmony, it's in equilibrium. So net force is zero. That's why we are not accelerating. I'm not falling down. Okay? Yeah. So no force, ergo, therefore, no acceleration. So accelerometer reading will be zero. And our body is kind of like accelerometer as well. Okay? So actually the observer can tell the difference between gravitational force and accelerative force. A man in spacesuit, in a chamber, in a space rocket, out in the space, accelerating, and man in this astronaut in a space shuttle that is just waiting, sitting idle on planet Earth's surface, yeah, this astronaut can actually tell the difference between accelerative force and gravitational force. Because his body is kind of like accelerometer, he can tell the difference. Okay, so Mr. Einstein was wrong again, right? How interesting. Let me write that down. I already did, but when it comes to no net force, no acceleration. Okay, good. We're making progress. So what's the temperature outside? It's like 38 degrees. Okay, so it went to 30s this morning. Yeah, it's autumn. Yeah, it's like Alaska during the winter time. It's kind of creepy. Okay, yeah. So that's why ladies don't like Alaska very much. Creepy winter and also like Arctic wind. Every now and then in Alaska we have Arctic wind. They're very strong wind for a very long time. It lasts like couple of days sometimes, or maybe not couple of days, but maybe like for 10 hours, half a day. Yeah, strong, continuous wind. Yeah, it's Arctic wind. In this town we have that. Okay. So yeah, Alaska there are more guys than girls. Okay, so but that's fine. Just like I heard, I was in Cornell University, right, Ithaca, New York, and but Cornell University Medical School is in New York City, Manhattan. Okay, yeah, I did some internship there during one summer when I was doing PhD. Okay, so yeah, I was doing computational biology, like bioinformatics, yeah, systems biology, yeah, like proof time folding, in silico simulation of some biological phenomena, bioinformatics, sequence analysis, all that stuff. Okay, yeah, that was interesting. Yeah. So I heard that Cornell, the founder of Cornell University, is Ivy League school. Okay, a kind of low Ivy League, but so what? I mean, I went to Michigan Law School. It's a top 10, but kind of top 10 law school, but kind of like on the fringe, 10th or 11th, ninth, depending on the year, I guess. But so what? Still top 10, whatever, right? So yeah, Ivy League school, yeah, Cornell University. They, what I heard is that the founder of Cornell University, maybe it's Mr. Cornell or something. Okay, chose this remote location, Ithaca, New York, upstate New York. It's a very small town. Okay, college town. Uh, because he wanted scholars to be hermits, to be isolated from distraction of a big city. Okay, so that was the idea. So me being in Alaska, it's good isolation, away from distraction, so that I guess I focus on studying. No problem. Okay, we'll take 5 minutes. Oh boy. Okay. So I don't wanna like go back to what I wrote already in this general relativity proof paper and then correct it because it disrupts this natural flow of the previous writing. I don't want that. So maybe in chapter 6, so chapter 5 will be about special relativity disproof, and chapter 6 will be about erratum, errata, uh, correction of what I wrote before about general relativity disproof. I think that's what I'm gonna do. Okay. Or some addendum. Okay, so there's one correction I made, right? Yeah, oh yeah, photon. I gotta write this down. Photon, it is subject to friction force. Curved path in gradual, graduated density medium glass. Okay. Give me 1 second. Okay. Yeah. So let's conduct some sort of experiment like a graduated density medium, some glass. Yeah, we can control the density of glass or water, right? Yeah, I mean, you have slab of water container, right? And this water contains some salt. Next level, this slab of glass container, okay, kind of rectangular shaped, okay. So, and next level will be more denser and denser water. We put salt in there, okay, so that's the transparent. Yeah, more salt, more salt, more salt. Then light will go like initially it goes like this, and then like this. Okay, okay. Yeah. Mm-hmm. Yeah. Light is not that high and mighty. Okay, it does slow down depending on the density of a medium. It can also stop. Photon is not God, huh? Like Mr. Einstein was thought. Okay, no. So yeah, this special relativityism is nothing but a religion in disguise, disguised as science, but it's worship of light. Like back in the days in Egypt, sun god Ra, and also some Christianity. Christianity doesn't really worship light. It regards light as a virtuous object. Just like in Taoism, they see water as very virtuous object, very adaptable water. Okay, yeah. Also, water sustains life too. So does light. Okay, but water can kill people too. Right? Drowning, tornado, not tornado. Yeah, tornado is wind. It can kill people too, right? And light, I mean, yeah, it can kill people too. I mean, if you're in the desert, the sunlight, sunburn, dehydration. Okay, so if you get too close to the sun, star, yeah, you don't want that, right? Because people's body will start burning. Light is hot, okay? Too hot sometimes. Also, light it can cause skin cancer too, right? Yeah, I mean, some people die from skin cancer. Okay. Yeah, so it's highly advised that people don't expose themselves too much to sunlight because ultraviolet light it can damage the DNA and cause skin cancer. Okay, so yeah, we are mindful of that. So when I go to beaches, I'm fully clothed. Okay, I don't sunbathe. I don't do that. Yeah. Even when I swim, I don't get naked. Okay, I have my wetsuit, like tight fitting, some not sweater, but some tight fitting this long sleeve, whatever. Okay, yeah, so that it don't doesn't get too much resistance when I swim. That's what I did. I went to San Diego last year. Okay, around this time, October last year. All right, as a vacation. Also, they had some continuing legal education class, like about over 3 days. Okay, I had to pay for it. It was like $600 or something. Okay, but yeah, 1 week vacation package, like car, airplane, hotel, $1,000. Great deal, right? So yeah, I mean, so $100 and I mean $1,000 this vacation package plus 500 about $500 this class fee. That's $1,500, right? My PFD pay for that. Yeah, in Alaska we got about 1,500 every year. Uh, PFD, permanent fund dividend. Okay, so yeah, I go vacation with that money. Okay, so it's October. Yeah, PFD is coming. That's good. Yeah. Let me write that down. So how does light stop? If there's this, let's say black body, the black body experiment. Okay, so yeah, very absorptive. Okay, you have this soft surface, not glossy. Then light will bounce. Some of the light will bounce off, right? But some uh, paper or sponge that is black, right? Then light wave, this wave energy, electromagnetic wave energy, photon, its energy will be absorbed and convert into heat energy and absorbed by this black sponge. Yeah, the photon will stop traveling. Okay? Yeah. What is heat energy? It's nothing but kinetic energy of molecules, like oscillation. Okay, so yeah. Mm-hmm. Let me write that down too. Yeah, photon can stop. It doesn't have to travel in the speed of c all the time. No, no. Yeah, so photon does slow down. It can also stop with velocity zero. Okay, and yesterday in our soil experiment, we created a standing still photon. Okay, it's not been converted to any other energy form. It's just standing still. Yeah, we created that yesterday in our thought experiment. Okay, yeah, that was cool, wasn't it? Yeah. So many things to write down. Okay, my goodness. Maybe this evening. Okay, yesterday's evening. Yeah, I wrote like 5 pages. Okay, over like about 3 hours. I wrote quite a bit yesterday. So this evening, if I feel like it, I write again. But if not, we call it a Sabbath, alright? Because no, I kind of took Sabbath because Friday and Saturday, I don't think I wrote anything, alright? So, okay, if I feel like it, I write again because daylight is burning, right? Yeah. But there's no rush, there's no deadline, okay? That's the best part. But at the same time, I don't keep the ball moving. Yeah, we'll see. Yeah. So happy holiday, happy Columbus Day. Okay, yeah. So why did I dress up like this? Because I don't know. Okay, then I realized, yeah, it is holiday. Okay, so yeah. Has it ever happened to you? Like you wake up and you are ready to go to work, and you realize, oh, it's holiday. Oh, great, right? Yeah, it was like that. Okay, so yeah, we'll take 5 minutes break. Okay, yeah. We'll stop and restart because it's been almost 1 hour. So, all right, I'll see you soon.